Okay, in this video I wanted to talk about doing trigonometric problems using bearings. Now, bearings are usually used to measure directions and distances, and what they do is they start off by using a reference point. Okay, so usually what they do is they take some north-south reference point, okay, like this. And so we have north, south. Okay, I'm not going to draw the east, west, and south. But basically what they do then is they give you a distance and an angle. And the angle is always measured from north. So 0 degrees would be going north, and it's always measured clockwise from north. So if I was going, say, at 45, or let's say 50 degrees for 10 kilometers, or something like that, what it would mean is that the angle would be something like this. The length of the angle would be 10 kilometers. Okay, so the length of the line would be 10 kilometers, and the angle here would be 50 degrees from north. Okay, usually then what they do is they'll say that this is a point A and this is point B, and then from point B the person will, or the vehicle will move at a different bearing or a different heading, and then you just basically have to track them all around. So I'm going to start with a typical example here. In this case, a fictional girl, Emily, decides to walk from her home to her favorite bubble tea cafe. And from her home she walks 2,000 meters, so 2 kilometers, bearing 80 degrees. Then she walks 1,000 meters, bearing 200 degrees. What is the straight line distance between her home and the cafe? And this is a very typical type of example. Okay, so what we do is we start off by just finding the original directions and finding out where she went. Okay, so what we do is we'll start off by just drawing a northeast, southwest cross here. Okay, good. Okay, so I'm going to draw a diagram and just estimate like what her path would have looked like. Okay. Okay, so the first one said that this is north. Okay, now so the first thing that she did is she walked 2,000 meters bearing 80 degrees. So what we're going to do is draw a line representing that path. Okay, and let's see, so she starts here and she goes, I don't know, let's say that's 2,000 meters. Okay, it doesn't have to be exact, doesn't really matter actually at all, as long as the diagram is reasonably accurate. Okay, now bearing 80 degrees means that this angle here is 80 degrees, and it means that the length of this line is 2,000 meters. Okay, as I said, is that in physics this is known as a vector, and what we can recognize is that this is made up of several different components, and we're going to take advantage of that later on. But nonetheless, she moves after she does this. Okay, then what we're going to do is create a new reference point from this second point here. And I should have made that a little bit bigger. Okay, once again, it doesn't matter if you're 100% accurate here, because what we're doing is just making a little diagram to help us understand all the different pathways and stuff like that. Okay, so from here she then walks 1,000 meters on a bearing of 200 degrees. Now 200 degrees, if I start at north and go to this x-axis, it's 90, and then to this y-axis it's 180, and so 200 degrees is basically something like this, and it's about half the length of this line, so something like that. Okay, and this is 1,000 meters, and this is 200 degrees. Alright, now what the question then asks is, what is the straight line distance between her home and the cafe? And what I'll do is I'll put an A here, just to say that's where she started, B is where she stopped, and C is where she ended. Okay, and maybe C could stand for cafe or something like that. Okay, so it means what is this distance? That's what it's asking, the distance on the purple line. Okay, now in some cases the geometry will just work out that this will be 90 degrees. Okay, so that you can just say, hey, this is a 90-degree angle, and then we can work on this just as if it were a regular 90-degree triangle, right triangle, and just use our sine, cos, tan, and Pythagorean theorem, and just solve the whole thing. But in most cases, that's not going to work. Alright, so the way that we approach this then is that we look at each of these vectors, okay, so each one of these paths as on its own, and we break them down into horizontal and vertical components. So I'm just going to take the first one from A to B, and I'll show you how this looks like. Okay, so if I went from here, okay, so as I said, it doesn't have to be perfect. Okay, I end up with something like this. Okay, this is A, this is B, okay, and this length is 2,000 meters. Alright, and now what we can do is we can extend this out like this. So we can say, you know what, like, let's say walking from A to B is pretty much the same as walking from, let's see here, I'm just going to clean this up a bit here. Okay. It's pretty much the same as walking from here to here, and then walking from walking from here to here, and then walking from here up to B. Now, your overall distance walking in the non-straight line path, so along the red path, would be longer, but your overall displacement would be the same. So what I mean by displacement is the difference between where you start and where you end is going to be the same, right? So you'll end up basically in the same spot. And this angle here, because this angle is 80, this angle must be 10. Okay, now from this, what we can do is we can break this down and find out how much across she walked and how much up she walked, or north, and how much east she walked and how much north she walked. Okay, so the way I do this is I could say that the cosine of, I'm going to run out of space here, so I'll just make this a little bit easier, make a little space here, and I can say that the cosine of 10 degrees is equal to, we'll say this A over hypotenuse, which is 2,000 meters. Okay, and that means that A is equal to 2,000 meters times cosine 10 degrees. Okay, and what we'll find is that, and I think I worked this out already, is, I'll work it out again here, is 10 cosine times 2,000. Okay, is 1,969.6. 1,969.6 meters. Okay, that means she walked 1,969.6 meters across. How much did she walk upwards? Okay, well, let's see. We would say sine of 10 degrees is equal to the opposite. Okay, so opposite over hypotenuse, so 2,000. And what we could say that is the opposite is equal to 2,000 meters times sine of 10 degrees. Okay, and then what we would know is that the opposite is equal to, so this is 10 degrees sine times 2,000. Okay, so that's 347.3. And it kind of makes sense. If I was only walking at 10 degrees, most of this angle is going to be in the horizontal direction, not in the vertical direction, or in the east direction, not in the north direction. And so it does make sense that the vast majority of it would be along the eastern line. Okay. So what I've done is I've broken this down, and I'm just going to summarize these because I'm going to run out of space for my calculations if I don't erase these other parts here. Okay, so what I have is that I'll say this is AB in the x direction, so along the x-axis, is equal to 1969.6 meters. Okay, and AB in the y direction, okay, is equal to 347.3 meters. Okay, and basically it's positive because I'll consider going east to be positive and north to be positive. And if it was going south, then it would be negative, and west would also be negative. Okay. Okay, now I'm going to get rid of these because I'm going to need the space. Okay, let's take a look at this other bearing here from B to C then. Okay, so from B to C I've got something like this. Okay, and starting there, I've got something like that. Okay, now the length of this line is 1,000 meters, and the angle here, okay, the entire angle is 200 degrees. Okay, now what this means is that this angle here, because starting at north, going all the way to south is 180 degrees, and it went 200, so it went 20 degrees further. Okay, I'm just going to extend this line a little bit. Okay, and what we can see is that essentially this would be the same, and I'll draw these in red again. Oops. It would be the same as if she had just walked down and then across. Okay, and again, as I said, the overall distance that she walked would have been different, but the displacement, so the difference from where she began and where she ended, would be the same. Alright, now once again I'm going to do some trig calculations with this and find out how much south she walked and how much west she walked. Okay, now I have an angle, and in this case I've got, and I'll call this B and C. Okay, so I've got an opposite of 20, okay, and adjacent over here. Okay, so I call this A, this one O. Okay, so opposite and adjacent of 20 degrees. It looks like a 28, but that's actually 20. Okay, so what I can say is that the cosine of 20 degrees is equal to A, so the adjacent divided by the hypotenuse, so that's 1,000 meters. Okay, which means that A is equal to 1,000 times the cosine of 20 degrees. Okay, and that means that A is equal to 20 cos times 1,000. Okay, so that's 939.69. Okay, so 939.7 meters. Okay, the opposite, so it can be found using sine. So sine of 20 degrees is equal to the opposite over the hypotenuse, which is 1,000 meters. And what I'll get is that the opposite is equal to 1,000 meters times sine of 20 degrees. Okay, and that the opposite side is now, let's see, so 20 sine times 1,000. So that's 342. Meters. Alright, now what this means, and as I said before, what I'm going to do is say that north and east are positive and south and west are negative. Okay, and so what this means though is that from B to C, the x component, okay, which is the opposite, so it's the horizontal component, okay, is 342 meters negative. Okay, so it's going in the negative direction. okay, and BC in the y direction, okay, and it's starting from here and it's going down, so it's negative as well, is equal to negative 939.7 meters. Okay, now once again, to save space, I'm going to have to get rid of these here. Okay, so what I've done here is I've broken down both of these vectors, so both of these trajectories, into their horizontal and vertical components. Now what this means, okay, is that if I were to just look at, say, just the horizontal part, if I went from A to B, I would go from here to here, and then I would backtrack a little bit, which means that the distance, okay, the sum of all of these, okay, I'll use orange here, is this distance here. Okay, so it's the same as if I started here, walked all the way to here, okay, and then came back to here. Okay, and the horizontal or the vertical part would be the same as if I walked. Okay, so once I got here, would be if I walked up to B and then back down to here. Okay, so, and what you'll find is because one's horizontal and the other one's vertical, that they form a right angle to each other. Okay, and then this side length, okay, and I'll just magnify this here. Let me just split off the work here for a second. Okay, so often like to do this with my work is just to draw little lines around to demonstrate that like each part is separate from the others here. Okay, so that way, if someone's looking at my work, it seems like to me it seems like it's easier for someone to follow, because what they can do is they can see that this is supposed to be one section, this is supposed to be another section. Okay, and then clearly it's split off from the rest of it as well. Okay, so what I'll do is I'll redraw this here. So what it would be the same is saying is that this purple line, okay, from A to C is made up of two components. Okay, and I'll draw them back in orange again. Okay, it's made up of one like this, okay, and one like this, and they form a right angle to each other. Okay, I'm going to go a little bit darker here, so go dark orange here. Okay, so what this means then is that this distance from A across the horizontal would be 1,969.6 meters minus, okay, because it came back, minus 342 meters. Okay, and so what I get is 1,969.6 minus 342 is 1627.6. So this is 1,627.6 meters. Now, as for the vertical direction, it's the same thing. Is that this one, it would be walking the same as 347.3 meters going up, and then coming back down negative 939.7 meters. And so this distance in total is 347.3 minus 939.7, and I get negative 592.4. So I'm just going to write 592.4. The negative just indicates that it would be moving downwards, okay, that the person walked downwards. Okay, so I end up with a triangle like this. Okay, and what it means is that I can use the Pythagorean theorem then to find out the length from A to C. And so I'm just going to, once again, erase these these work things. Now, I would suggest that if you're in school and you're not just doing this for fun or whatever, that you should actually not erase your work. Okay, because a lot of times you can get extra marks or part marks or something like that in questions if you can demonstrate that you're kind of following along the right thing. Okay, so okay. And what I can do is I can say that the length A to C squared is equal to, we'll call this, I don't know, theta. Okay, so, well, people probably don't like theta. I'll call this D. Okay, is the same as AD squared plus DC squared. Okay, this is just the Pythagorean theorem. Okay, so what I have is AC squared is equal to 1627.6 meters squared plus 592.4 meters all squared. Okay, and then we can figure out what the answer of this is. So what we'll get is AC is equal to the root of, and this number I'm going to expect is going to be pretty big. Let's see, 1627.6 squared plus 592.4 squared equals, okay, so that is 3,019.52. Okay, so 3,019.52 meters squared, and so the square root of that. So AC then is equal to 1,732 meters. Okay, so the distance, so walking from A to B for 2,000 meters and then from B to C for 1,000 meters is the same end result as if you just walked from A to C for 1,732 meters. Okay. Now they could also ask you, for instance, like what the angle, what the final bearing was, and what you could do is you can just use the same trig functions to find this angle here. Okay, so let's say we had this angle theta, and then what we could do is just add that to 90, so it's 90 plus theta is their final bearing. I guess I could solve that here. Okay, so what I'm going to have to do is get rid of some of this other work because I'm running out of space rapidly here. Okay. Okay, so there's the final triangle. So that's the distance, and if I wanted to find the angle theta here, okay, what I could do is I could say that, and now I have the opposite and the adjacent, so I could say that tan theta is equal to opposite, so 592.4 meters divided by 1,627.6 meters. Okay, and then I know that tan theta is equal to, okay, so it's 592.4 divided by 1,627.6. Okay, so 0.36397. Okay, and then using my inverse tan function that I don't have on the calculator on the computer, what I would have is, let's just see here, .20 degrees. Okay, that worked out really well. Okay, so 20 degrees. Okay, and that means that the final bearing that the guy walked, or Emily walked from, is this 90 degrees plus another 20, so the bearing was, okay, so this is 90 degrees plus 20 degrees equals 110 degrees. Okay, and so this would be your final bearing right here. Okay, and so anyways, that's how you find out, that's how you use bearings to solve problems in trig. Almost certainly, it's always like a vehicle or a person traveling. And the real trick is just to break up each one of these vectors or each one of these paths into its horizontal and vertical component, and then just add them and subtract them from each other to make the final length. All right? It's a common tactic that's used in basic physics. And it's really, really helpful. One of the simple things, rather than trying to resolve the triangle by trying to cut it up into other right angles and whatnot, it's way easier just to break down each one into its horizontal and vertical component. Anyways, if you have any questions, drop me a line, put a comment in the comment box, or send me an email. If you like the video, please give me a thumbs up, and if you like my channel, then please subscribe.